So in the chapter of gravitation, till now we have seen first of all what was gravitation, then the universal law of gravitation, universal law of gravitation. Then we also saw the variation in the value of g, variation in the value of g, that it was maximum on the poles and minimum at the equator. Why? Because of the bulging of the earth on equator. Then we also saw the difference between mass and weight. Now in today's video we will see about the next topics from the same chapter. Now we will start with thrust and pressure. So first of all we will discuss what is thrust. But before understanding the concept of thrust, we'll first need to recall what was a force. Whenever there is an action of pull or push, we called it as force. It was called as force. We also saw the four effects of force, two types of forces, that is balanced and unbalanced force. But if this is any surface and I apply a force like this, condition A, I can also apply force in this way, condition B. But when I have a certain angle, that is an angle of 90 degree, that is perpendicular, this perpendicular force is called as thrust. Rest, this case A, case B, these are not called as thrust. They are simply the force which is causing the action of pull or push on this surface. But whenever we have a perpendicular force acting on any surface, we will call it as thrust. Thrust is nothing but a concept of perpendicular force. Perpendicular force acting on any surface is called as thrust. And this is all about the thrust. Once we get about the thrust, we will now understand what is pressure. The formula to calculate pressure is force upon, sorry, not force, we will use thrust upon area, its SI unit. Now thrust was nothing but a force under some condition, right? So thrust will be in newtons as always, and upon area, area is measured in meter square, and 1 newton per meter square is also called as 1 Pascal. This is also important, and SI unit is also important. We knew that the thrust had magnitude plus direction, but in case of pressure, pressure will only have magnitude and there will be no direction. So where do we use this concept of pressure? You have seen that the tires of bus or any big truck are wide as compared to the tires of any motorcycle or any bike. Why? Because bus and truck will be having a larger weight as compared to motorcycle, and this weight will also be applying in the perpendicular direction towards the center of the earth. We have seen in the topic of the gravitation in the lecture before. So because of which we will have to reduce the pressure. So how we will reduce the pressure? We can see that the pressure is inversely proportional to area. If we increase the area, the pressure will start decreasing. So by increasing the wideness of the tires of the bus and truck will reduce the pressure which is acting on the tires. In the same way, if the motorcycle, here in this case the motorcycle is having less weight, so we can reduce the area also so as to keep the pressure constant. So this is how we understand the concept of pressure and its real life application. It can be also seen using an example of, if we have some mud and we place two brick, one brick is placed in this vertical position and the another brick is placed in horizontal position. So in this case the vertical brick will sink more as compared to the horizontal. Why? Because in this case the area upon which the weight of the brick is being applied is less as compared to the brick which is placed horizontally. Area is less, therefore more pressure, and here the area is more, therefore less pressure. And from this we can also infer that pressure is inversely proportional to area. Means if area increases, the pressure will start decreasing, and if area decreases, pressure will start increasing. They are inversely proportional to each other. So this was all about thrust and pressure. The next topic we have is pressure in liquids. This is a very small concept given in the corner of your book, but there can be a question asked upon this concept in your exam. So in which way? We know that liquid will also have mass. Liquid will have mass, and if anything has mass on earth, it will have some or the other weight which will be directing towards the center of the earth, and because of this direction it will be applying a force on the walls of the container. So it will be applied in the downward direction as well as in the sideways direction. Actually it is in all directions. The force applied by the liquid in any container is in all direction. This is also a question which can be asked, that the liquid placed in any vessel applies pressure only in downward direction, sideways direction, in all directions. So in that case you will need to choose the answer as in all directions. Okay, why? Because any liquid has some mass, and if there is mass, it will always have some weight on the surface of earth, and this weight is applied by the liquid in all directions on the vessels, on the walls of the vessels. So this is the question which can be formed from this concept. And then after the concept of pressure is finished, we'll have a next topic, that is buoyancy. So till now we have understood that gravitation is a force applied on any object, and the object is attracted towards the center of the earth, right? But the buoyancy is completely opposite. The earth will try to pull the object towards its center, and the buoyancy will be the force which will be acting against the gravity of the earth. Under which condition? So it is a property of fluids buoyancy is first of all property of fluids. Now first of all, what comes under fluids? Fluids is combination of liquids and gases. So this buoyancy is a property which is shown by liquids as well as gases, but not by solids, because solid is not a type of fluid. So when the buoyancy will start acting, if we have any vessel which is filled by some liquid, and in that if we have any object placed in it, so we have seen that some objects float on the surface of the water while some start sinking. So why this happens, that the object starts floating? This is because of the concept of buoyancy. Now we'll understand what is buoyancy. It is a property of fluids because of which it applies a vertically upward force. What is buoyancy? It is the force exerted by fluids. Force exerted by fluids. Now in this case it is a force, so it will have a magnitude as well as direction. So the direction of this force is opposite to that of the gravity. Right? First of all, it is a property shown by only fluids. Fluids consists of gas as well as liquids. It is a force. Buoyancy is a force which is exerted by the fluids, and the direction of the force is in the opposite direction to that of the gravity. Gravity acts towards the center of the earth, but the buoyancy will act away from the center of the earth. Okay, so which phenomena do we see because of the buoyancy? We see the phenomena of the ship floating on water, ship floating on water. Then we also see that plastic mug floating on water. So this is all because of the concept of the buoyancy. And this force which is acting opposite of the direction of the gravity, we have seen that the force which was acting perpendicularly downwards or perpendicular on the surface was called as the thrust, right? Any perpendicular force was called as thrust, but the force created by the buoyancy which will be opposite to the direction of the gravity will be called as upthrust. Will be called as upthrust. So this is also one of the questions which can be asked from this topic, that buoyant force is also called as upthrust. Now up next we have the Archimedes principle. Archimedes principle. Till now we have learned that there is a force which is exerted by the fluids whenever an object is placed into the fluid, and which acts in the opposite direction of the gravity, and it is also called as the upthrust. आतापर्यंत आपल्याला फक्त एवढं कळलं की एक फोर्स ऍक्ट करणार आहे. पण त्या फोर्सचा आता मॅग्निट्यूड किती असेल, डायरेक्शन तर आपल्याला कळाली की इट विल बी ऑलवेज इन द अपोजिट डायरेक्शन ऑफ द ग्रॅव्हिटी, बट व्हॉट अबाउट इट्स मॅग्निट्यूड. तर मॅग्निट्यूड जे आहे वी विल गेट इट फ्रॉम द आर्किमिडीज प्रिन्सिपल. तर आर्किमिडीज प्रिन्सिपल काय सांगतं, द फोर्स exerted by the fluid on the object is equals to the weight of the fluid, weight of the fluid displaced by the object. काय आहे, it is equals to the weight. weight काय आहे, weight is also a type of force which is acted because of the gravity. Then this force is equals to the weight of the fluid displaced by the object. काय डिस्प्लेस करणार आहे आपण, जेव्हा पण एखादं ऑब्जेक्ट पाण्यामध्ये टाकू किंवा कोणत्याही फ्लुइड मध्ये जर टाकलं तर इट विल कंटेन सम ऑफ द अदर व्हॉल्यूम, अँड दॅट व्हॉल्यूम ला आपण काय करणार आहे, त्याच्या डेन्सिटी सोबत मल्टिप्लाय करून वी विल गेट द वेट ऑफ द fluid displaced. सो बॉयंट फोर्सचा जर फॉर्म्युला आपण बघितला तर बॉयंट फोर्सचा फॉर्म्युला आहे रो इंटू व्ही इंटू जी. सो व्हॉट इज दिस रो? रो स्टँड्स फॉर द डेन्सिटी ऑफ द फ्लुइड. आता याच्यामध्ये नेहमी डेन्सिटी ऑफ द फ्लुइड विल बी considered while calculating the buoyant force. The density of the object is of no use when we are calculating the buoyant force. Then we have v. V is the volume of the object immersed. आपण त्या इमर्स केलेल्या म्हणजेच काय बुडवलेल्या ऑब्जेक्टचं व्हॉल्यूम किती बुडवलेलं आहे आपण, नॉट द टोटल व्हॉल्यूम. अँड जी स्टँड फॉर द ग्रॅव्हिटी. आता रो इंटू व्ही दॅट इज डेन्सिटी. डेन्सिटी इंटू व्हॉल्यूम केल्यानंतर वी विल गेट मास, अँड मास मल्टिप्लाइड बाय ग्रॅव्हिटी विल गिव्ह अस द वेट, अँड इन दिस वे वी कॅल्क्युलेट द buoyant force exerted by any liquid. आता इथून आपल्याला हे तर कळालं की buoyant force कॅल्क्युलेट कसा करायचा. बट how can we determine that any object will sink or float? हे तर नाही कळलं ना. We can calculate the buoyant force, but what about the condition for which we can determine that the object will sink or float into the fluid? So for that we have the concept of relative density, and this relative density is also called as specific gravity. Now first of all, what is this relative density? We will understand it first by the formula relative density. Formula is the density of object divided by density of water at 4 degree Celsius. And relative density will never have any unit. It is a unitless quantity, and so is our specific gravity. दोन्ही काही नाही, दोन्ही पण सेमच गोष्ट आहे. रिलेटिव्ह डेन्सिटी इज ऑल्सो कॉल्ड एज स्पेसिफिक ग्रॅव्हिटी. सो आता इथून आपल्याला कसं कळणार की द गिवन ऑब्जेक्ट विल सिंक ऑर फ्लोट इफ relative density, I will write RD, relative density is greater than 1. Means what? The density of object is greater than the density of water at 4 degree Celsius. So in this case, the object will sink in the water. इथे आपण काय केले, वॉटर सोबत कंपेअर करतोय आपण. सो विल ऑल्सो कंपेअर इट इन द केसेस ऑफ द वॉटर ओनली. जर आपल्याला दुसरा कोणत्या फ्लुइड सोबत चेक करायचं असेल तर वी विल हॅव टू चेक द डेन्सिटी ऑफ द फ्लुइड. In this case, we are considering the water, so we are also considering the case when it will sink or float in the water. And if the relative density is less than 1, the object will float. The object will float on the water. And if relative density is equals to 1, the object will float inside the water. This is also an important case, float inside the water. आता float inside the water म्हणजे काय, तुम्हाला याची इथे डायग्राम बनवून दाखवतो की ऑब्जेक्ट जे आहे इट विल बी कम्प्लिटली इनसाइड द लिक्विड. पूर्ण खाली गेलंय का, नाही. पूर्ण थोडा पार्ट वरती आहे का, नाही. इट इज कम्प्लिटली अंडर द just the surface of the water. This will be called as to float inside the water. And there is one more point from which the question can be formed, that whenever an object, what I'm saying, whenever an object is immersed into any liquid, there is a drop in the weight of that object. Why? Because of the upthrust. Upthrust काय होता, the force acting against the gravity because of the fluid. It was also called as the buoyant force. So it is the buoyant force which will reduce the weight of an object whenever it is immersed into the fluid. Okay, and we have also calculated the formula to calculate the force, that is rho Vg, where rho stands for the density, V for the volume, and G for the gravity. From using this formula we can calculate the force, and this formula was given by the Archimedes principle. What does the Archimedes principle says? The force exerted by the liquid, or the buoyant force exerted by the liquid, is equals to the weight of the total fluid displaced by the object. And then we have seen the relative density, also called as the specific gravity, which relative density is a formula, that is the density of object divided by the density of water at 4 degrees Celsius. Relative density is a unitless quantity, and if relative density is greater than 1, the object will sink. If it is less than 1, the object will float, and if it is equals to 1, the object will float inside the water. And with this we end our chapter of gravitation.